Science guy.
Whoa, no. You have the wrong show. I'm not Bill Nye.
You're not?
Bill Nye's the next house over.
Who are you?
I'm Ron Watt, and this is Cooking with Chemistry.
Hey Ron, I was wondering, when cooking do you encounter chemical reactions or physical changes?
Actually, girls, we encounter both physical changes and chemical reactions during cooking. Because when you mix two ingredients, sometimes they just form mixtures and keep their own identities, but other times they combine with each other to form new compounds. For example, when butter heats up, it melts, and that's a physical change. But when baking soda heats up, it creates carbon dioxide gas, and that's a chemical change. To prove this to you guys today, we'll be baking a cake, and the ingredients we'll use are all-purpose flour, brown sugar, cocoa powder, baking powder and baking soda, salt, and canola cooking oil, buttermilk, 2 eggs, vanilla extract, sugar, butter, and chocolate chips. So first we have to mix in all the dry ingredients. So we'll start by adding 1 3/4 cup of brown sugar. Next we'll have 1 3/4 cup of flour. Then we'll add in 3/4 cup of cocoa powder. And this is a mix of 1 1/4 teaspoon of baking powder, 1 1/4 teaspoon of baking soda, and a 4th teaspoon of salt. There you go. Now you mix it up.
Now this is a mixture, right?
Yes, this is only a mixture. No chemical changes have taken place yet.
Now that our dry substance is fully mixed, what are we doing next?
We'll go over and mix the wet substances. Here we'll have 1 1/4 cup of buttermilk. Go ahead and pour it in. Then pour in the 4 tablespoons of oil.
Whoa!
Oh yeah, that's cool.
Look at this. The oil and the buttermilk don't mix. Why is that?
That's because oil is resistant to buttermilk and to also a lot of other substances. It doesn't like to mix with other things.
So no matter what you do, it will never mix?
Sometimes you can shake it, but that'll only make it smaller bubbles, so it'll look like it's mixed. But then if you leave it, it'll separate out again.
Oh, interesting.
Yeah. So now you can go ahead and crack 2 eggs in there.
This is dangerous. Why don't you crack the eggs?
Okay.
Why doesn't the egg mix with the substances?
Same reason.
Oh, I see.
Now we're going to measure out a teaspoon of vanilla extract.
1 teaspoon. What's 1 teaspoon? Yes, teaspoon. Right. Vanilla. Love the smell of this. I'm starting getting this open. Got it. Just 1?
Mm-hmm.
Is this chemical or physical?
This is all still physical. Nothing has created a reaction yet.
Alright.
Now go ahead and pour that water in.
Alrighty then.
Careful, it's hot.
Okay. Guess I'll do that parental supervision.
Now you can go ahead and whisk it up.
Okay.
Now that we've had both our wet substances mixed and our dry substances mixed, we'll slowly whisk the wet stuff into the dry stuff.
Hey Ron, is this chemical or physical change?
This is still a physical change. What's happening is that the dry stuff is dissolving into the wet stuff.
So it's just becoming a new, bigger mixture?
Exactly.
Oh, I see.
And if you do this correctly, it'll actually look like a solution because it'll look like just 1 chocolatey substances, not all the ingredients we started with.
Oh.
Got it. I'm starting to get it now.
That's good. We've already preheated the oven to 350 degrees Fahrenheit, and we're about to put the cakes in the oven. Careful, it's hot.
Don't burn yourself.
Now we set the timer for 25 minutes.
Now, is
Voila.
this going to create a chemical reaction?
This is where the chemical reactions take place. The baking soda will create the carbon dioxide gas and cause the cakes to rise. That's one of the chemical changes that's going to take place. Another one is that the eggs will harden, and that's another chemical reaction.
Oh, I see.
What we're doing now is we're heating the chocolate chips in a pan of simmering water, so the bowl doesn't burn, or the pan doesn't burn, or the chocolate chips don't burn.
Is this creating a chemical or physical reaction?
It's a physical reaction because we're adding heat to the chocolate chips, and that will cause them to melt, but they're still chocolate.
Oh, I like chocolate.
Don't we all?
Does that mean that the chocolate's changing state from solid to liquid?
Exactly. Now, for the chocolate frosting, what we're going to do is we're going to beat on medium-high the butter so it's light and fluffy. Now that we have some fluffy butter, we're going to add in 1 teaspoon of vanilla extract and 1 egg yolk. And beat it some more. There's a very little known kitchen secret that if you don't have confectioner sugar, may be able to save you the recipe. If you put regular, ordinary cane sugar into the blender and blend it on medium for about a minute or so, you get pure confectioner's, or aka powdered sugar. So we've got 1 1/4 cups of it here. And we're going to turn the beater on low and start gradually adding it in. Our cakes have just finished baking. 25 minutes gone by. Let's take a look. Do you see how the cakes have risen?
Is that from the carbon dioxide?
Yeah, exactly. The baking
So
soda.
the heat made the baking soda produce carbon dioxide, which made the substance rise?
Exactly.
Cool!
We just added the chocolate, melted chocolate, to the butter, sugar, and also 2 teaspoons of water. Now we're going to beat it on a low speed. Our chocolate frosting. See, girls, this is a tasty way to demonstrate science.
Awesome!